All right, so day 4 of Unit 3, derivative of an inverse. That's the shorter title, right? There's a longer title there, inverse of a function at a specified point, but really we just say derivatives of inverses. So first, some things about notation. 3 to the negative 1, that's 1/3. 7 to the negative 1 is 1/7. 4/3 to the negative 1, flip it over, you get 3/4. X to the negative 1 equals 1 over x. We talked about that with some of the exponent stuff. So it does, yes, it does. Sine to the negative 1, does that equal 1 over sine of x? Do you remember what that means? That's a no. The word's already on the page, by the way. It's the inverse sign. And it means go backwards. So like the inverse sine of 1/2. Face is frozen. Inverse sine of 1/2 means what angle has a sine of 1/2. So what's the answer to that? Pi over 6. So that doesn't mean flip 1/2 over and take the sine or something like that. It just means think backwards. Inverse means think backwards. So yeah, it'd be pi over 6. Sine of x is not a variable. Sine of x is a function. And when you see a function with the negative 1, it does not mean 1 over the function. It doesn't mean flip it over. So if it's a number or a variable, yes, do the flip thing. But if it's a function, it means inverse. Same thing with f to the negative 1. We're doing this in Algebra 1 right now. F to the negative 1 does not mean 1 over f of x. Jace?
When we're solving, are we only looking in the first quadrant? Or do we have to solve for each quadrant?
Well, you're talking back to this quadrant thing. Okay, this one was kind of tricky, and I thought about it as soon as I wrote that. Inverse sine has to come from first or second. Remember these restrictions, inverse cosine? Or excuse me, first and fourth. Well, it's related to all students take calculus. But yes, you only have one answer. And sine is 1/2 in 2 places. This is kind of what you're getting at. But you always want just a simpler answer. A more simpler one than that is square root of 9. Like there's 2 things that you could square and get to 9. But what's the square root of 9 equal to? 3. Not plus or minus 3, just 3. All right, that's a little side note there. Look, my face is frozen again down there. We're going to be defining the derivative of a function's inverse. How would you write the derivative of the inverse of f? Oh, so we got 2 sort of symbol things to think about. We know how to write an inverse, that's the negative 1, and we know how to write a derivative, that's the prime. So we're going to do f to the negative 1. Again, that doesn't mean flip f over. That means the inverse. But we want the derivative of that. So that looks kind of funny, but you got to do all of that to get the derivative of the inverse. All right, there's the prime meaning derivative, and there's the negative 1 meaning inverse. So that means the derivative of the inverse of f. All of that just for getting notations out. All right, a little bit of algebra review. Algebra review of inverses. If f and g are inverses of each other, then if AB is on the curve of f, then BA is on the curve of g. So let's say this one's f. That one's G. My face keeps getting frozen. I don't know what's going on. So if this is the point AB, then if we reflect it across y equals x, then that point is BA. The main rule of inverses is switch x and y. That's another way to think of it. So if you switch x and y, AB becomes BA if f and g are inverses of each other. The two curves are symmetric to each other across the line y equals x. Because if you let y equals x and x equals y, if you switch x and y, it makes sense that you would get a graph that's flipped across y equals x. You might remember this from algebra, composition. If f of g of x equals x and g of f of x equals x, then they are inverses of each other. Like, g does something to the function, f undoes something, g does something to x, f undoes that, and then you're back to x. Or the other way around. If f does something, g undoes it, and you're back to what you started with. That's what it means to be inverses. Okay, all of that was still algebra review, and kind of tricky algebra review. Now we're going to get to the calculus, the derivative of a function's inverse. Okay, if we know f and g are inverses of each other, we're going to try to find g prime from starting with f of g of x equals x. F of g of x equals x. I don't know that we've done this yet, but to your list of things you can do to both sides of an equation, like back in 7th grade you added 1 to both sides, and then on a two-step equation you would add 1 and then divide by 2. And later on you realized you could also square both sides or square root both sides. What we're going to do today is take the derivative of both sides. So the derivative, let's do the right-hand side first. That's the easy one. What's the derivative of x? 1. On the left-hand side, what's the rule I'm going to need? The derivative of f of g of x. Chain rule. So outside in, one layer at a time, f prime of g of x times, that's my outer layer, and my inner layer times g prime of x. And we did this to solve for g prime of x, because we're looking for the derivative of the inverse, because g and f are inverses. G prime of x is 1 over f prime of g of x. Okay, this is sort of the background proof of what we're going to use. You're not really going to have to do this every time. The main point of doing that is that we realize that the inverse functions have reciprocal derivatives. Inverse functions have reciprocal derivatives. Let's see. Inverses means switch x and y. Derivatives we usually think of as dy dx. Just trying to give another sort of proof or explanation of why they are reciprocals. Well, if we switch x and y, that would be dx dy, and that would be a reciprocal. So that's sort of the rough explanation of why derivatives of inverses are reciprocals. Again, there's going to be an easy way to make sense of this in a moment. If f and g are inverses of each other, then g prime, this is what we just said, is 1 over the derivative of f prime. The trick is, you're at different points on the graph, right? The AB, BA swap thing. So f prime of g of x. Let's make a table. I discovered this a few years ago. It helps me make sense of these problems, because when you're doing the problem, they're not bad, but then, 3 weeks later or a month later when there's a review question on a test, you're like, oh man, I don't remember the reciprocal. You remember that it's a reciprocal, but you can't remember what goes where. Here's a little table that I will do every time I do an inverse problem, because it helps me keep things straight. So if f and g are inverses, and if the point AB is on the graph of f, then what's the corresponding point on the graph of g? VA. Well, y prime, the derivative, usually we'll just take the derivative of f and plug in a. But here's the important box of this little square. The derivative of g at b, so at the corresponding point, is the flip, is the reciprocal of the derivative of f at a. These two boxes are reciprocals. I'm going to make that box every time I do an inverse problem. Otherwise, it's too hard to keep up with who's where. And you'll see this as we start these problems. So g prime at b is 1 over f prime at a. So they're reciprocals. That's the easy part. The part that gets confusing is, what point are we talking about? Well, if it's point A on, if x equals a on f, then it's x equals b on g. Let's do an example. If f of 2 is 5, f prime of 2 is 1/3, what is the derivative of the inverse of f at 5? Let's make the table. F inverse, point. Some people will put m here, like for slope, but I like y prime to kind of emphasize it's a derivative. Okay, and before I start this problem, the whole point of setting up this table is that these last two boxes are reciprocals. So if I can figure out one of them, I'll flip it over to get the other one. Okay, if f of 2 is 5, what does that mean the point is on f? 2, 5. Oh, so what does that mean the point is on the inverse? 5, 2. The derivative of f, it just told me this one, f prime of 2 is 1/3. So the derivative of the inverse of f at 5, these are reciprocals, so it's got to be 3. You look at your answer choices, they're all either, there's something to do with 3. Again, I can't recommend the table highly enough. Number 2, let's set up the table again. F is 3x cubed plus 5. We want f prime of, we want the derivative of the inverse of f at 8. F inverse, point, derivative. And what we're looking for is the derivative of the inverse at 8. So we want that box is what we're headed for, what we would like. Okay, 8. What is that 8? Where does that 8 go in my box? What is that 8? It's the x value of f or of the inverse? Of the inverse. So that 8 is going to go right there. Well, if that 8 goes there, where else does the 8 go? On the y value for the f. And I don't know what this is yet, but I'm getting close to finding this top derivative. In fact, if I know the y value is 8, I can set 8 equal to f of x to find the x value. So minus 5 divided by 3, x cubed is 1. So that means x is 1. Oh, I had to work backwards to find that. But now I can find f prime at 1. So I'll take a derivative of f and plug in 1. One thing at a time here. So f prime is 9x squared. So f prime at 1 is 9. But what goes in my yellow box down here? 1 over 9, because those two boxes are always reciprocals. And depending on the problem, they can give you all sorts of different information, but the main point is those two boxes are always reciprocals. So my answer is 1/9. But they can word these problems a bunch of different ways. Like this one, they started with the x value of the inverse, but they can start almost anywhere and sort of force you to figure out what goes where. Number 3. Let h be a differentiable function. Selected values of h and its derivative are given in the table on the right. Find, here we go, the derivative of the inverse of h at 5. I should pull popsicle sticks just to read that thing. The derivative of the inverse of h at 5. So there's a ton of numbers there. I'm going to set up a table. h inverse, point, and slope, or point and derivative. And I don't guess you need to set up all the, the lines in there, but I would set up the table. So which box, Ambria, what box are we even looking for here? Top left, top right, bottom left, bottom right. What's the answer to the question? What box is my answer going to appear in? Bottom right. So this is what I'm looking for. So like, first job is like, well, what box am I aiming for here? All right, Dylan, this 5 right here. Where can that go in my little table? What is that? Good, perfect answer. It's the x of the inverse of h. Okay, well if it's the x of the inverse of h, Jake, I don't even want to go to the table yet. What is that? What else can I fill out in my table, not in the provided table? So it's got to be the y of h, because the inverses, so the xy swap thing. I think we know this, but maybe it's helpful to still label that those are reciprocals. Whenever I get one, I can flip over and get the other. Okay, so if the y value of h is 5, Avery, can you figure out what the x value of h would give me a y value of 5? So I want my y value to be 5. Now I'm going to have to look at this table now. 10. So if my y value is 5, then kind of going backwards, figure out that that's 10. Ashlyn, what box can I know next? What box over here can I know next?
Top right.
And what's the top right equal to? Yes, at where?
At 10.
And so what is the derivative of h at 10? Negative 1/4. And so lastly, Seth, what goes in my yellow box for my answer? It'd be negative 4 because it's got to be the reciprocal of. And And that's why those are kind of confusing. It's like, that was a lot of like jumping around there. But at the end of the day, all you're doing is finding the reciprocal. So if you can find one derivative, it's the reciprocal, but at the corresponding point, so you've got to get those point things sorted out. I left one spot blank, but I didn't need it, so some students just leave it blank, it doesn't matter. Others want their table complete, so they put the 10 in there, whichever. Write the equation of the line tangent to the graph, meaning I need a derivative, of the inverse when x is 7. Inverse derivatives, and it's a pain, but the only way to keep it straight, or the only way I can keep it straight, is to set up the table. I've got to set up that table. Otherwise, I can't keep straight who's what and who's where. So I'm writing a tangent line, so I need a point and a slope. Point is 7 something. But Addie, x is 7, but x is 7 for which one? The inverse. So 7 goes in for the inverse. Forgot how many popsicle sticks I can pull on one of these problems because we're jumping all over the place. Jameson, how does that help me, or what goes next?
It's the y value of h.
So that means it's the y value of h. Abby, if it's the y value of h, what was the x value of h? 3. A little faster on this one. Stop me if you don't know where something came from. So, Jace, how does that help me? What do I learn next, or what should I fill in next?
For h inverse, you can put that in for the y. Or you don't have to.
Oh, I could put 3 in for y? Right here? Yep, I can. But I'll let you do that. You're right, it doesn't matter, but you're right. Austin, what else can I learn?
That h prime at 3 is negative 3 over 2.
I like it. H prime, yep, at 3 is negative 3 over 2. Oh, we're almost there. Therefore, Lexi, what's the derivative of the inverse of h at 7? Negative 2/3. And that's what we wanted. Oh, back to Jace's point. I did need that there because I need that for the point to write the tangent line. Y minus 3, negative 2/3, x minus 7. Again, you've got to draw the table on these because there's just too many. There's too many points, too many pieces of information. What is that? 6 pieces of information, like they're related, but how are they related? Again, the table is helpful. Number 4. If g of x is the inverse of f, f is the sine, find g prime at 1/2. All right, let's set up the table again. F and g. I'm just going to use f and g because it tells me that they're inverses. So point, a derivative. Again, the grid lines aren't necessary, but kind of forces my brain to slow down and see what's going on here. Okay, so g prime at 1/2. So that's what we want. That's what we're headed for, hopefully. Let's just start picking people off here. Brooke, what do I do first? What goes where?
X value for f is
Let's back up. Before we get to f, if I want g prime at 1/2, is that 1/2 an x value or a y value? Right, if it's in parentheses, it's an input. So it's an x value. Well, which x value is it? Is it the f x value or the g x value? It's the g x value. So McKenna, how does that help? What do I do next?
It's the y value.
Yep, that means it's the y value of the f. Autumn, so what? What do I do next?
Well, you plug it in
Okay, I like that. Plug it in where?
as the y.
As the y for
The f.
for the f, yeah, because we don't even have g. So 1/2 equals sine of 3x. Oh, now I got a pre-cal problem to solve. So, that's the one I gave at the very beginning. The sine is equal to 1/2 at pi over 6. So that means I need 3x to be pi over 6. So that means x is pi over 18. Lovely. Okay, but I'm getting close. Now I want to find the derivative of f at pi over 18. So I guess job 1 would be find the derivative of f. So Luke, how about the derivative of f? There's f.
Cosine 3.
Uh-oh,
Wait.
you ate the whole thing at once. It's okay.
Cosine 3x times 3.
That's better. Yes, cosine of 3x times 3. Ava, what next? Okay, so flipping it, yes and no. I don't really want to flip it yet because I'd like to get a value to flip. I mean, you could flip that over, but that would be kind of a pain to deal with. So I'd like to get this box filled in first, and then, you're right, I will flip it to get my final answer. So what should I do to fill in this box? Okay, so I want y prime, I got that, at pi over 18. So how do I find at pi over 18? Plug in pi over 18. So f prime at pi over 18, 3 cosine 3 pi over 18, 3 pi over 18, also known as pi over 6. The cosine of pi over 6 is root 3 over 2. So I've got the derivative, 3 root 3 over 2. And I'm almost there. All that's left is to flip it over. And you start looking at your answer choices, and they didn't even bother to fix it. They just flipped it. 2 over 3 root 3. None of the derivatives are really that hard when we do inverse problems. It's just like record keeping. Who goes where? X, Y, Y, X, F prime, but flip to get G prime. So you got to write the table to keep track of everything, I think. There's students who every year don't write the table and they just have stuff written all over, and sometimes they land at the right spot, sometimes not. But man, it's a whole lot easier to keep track of your stuff if you make that table. It's also a lot easier for me to give you partial credit if I can see, where you went wrong, if you went wrong. All right, I don't think we need to do all of number 5. Why don't you just try A? You try A, and then we'll be done. If you can figure out A, we'll be good. More comment on making a table. Like, I don't know what your answer is yet, right? Like, it's there, but you haven't told me which one is your answer. I guess maybe you're insinuating with the highlight, but that's a little bit, like, make sure that you somehow tell me that your answer is 1/4. Usually boxing it will suffice, but If everything is boxed, then I don't know what I'm looking at. So again, make sure you indicate what the answer is. All right, the rest of them is just more practice of the same stuff, so you don't need to do those two. So today's assignment is worksheet 4. Just as a reminder, as you peek ahead, worksheet 4 today, we'll do how you want to divide up the rest of the worksheet. The review is up to you. I'm not sure yet exactly what we'll do in class, but one of those classes I'll work a bunch of them. If you want to think of breaking them up odds and evens, that's fine. If you want to do some of them over the weekend to start studying, that's not a bad plan. But we're done with new material, so hopefully you're ready to go.